All right, we're going to start by going over weathering and erosion. So we're going to go through each of the unit concepts from this unit, and our unit was weathering and erosion and mass movement. So weathering and erosion, there are two types of weathering. If you said one was chemical and the other physical, then you were correct. Chemical weathering includes oxidation or rust, hydrolysis or reaction with water, acid rain, which can include any type of pollution that's turned into acid rain. It's predominantly carbonic acid. Then dissolving. That would be dissolving it into its ionic form. We'll try to get that. There we go. A little bit better resolution for you. And then those are your chemical weathering. So you're changing the actual composition of the material with chemical weathering. Now, physical weathering would include things like exfoliation, or the stripping away of outer layers of a rock. Frost wedging, where rocks are actually weathered by water getting into the cracks, freezing, expanding, and breaking into smaller pieces. Biological, which include animals and organisms such as ourselves moving things around and breaking them down in that manner. Erosion would be the movement of sediment. So we weathered it, we broke it down above, now erosion is going to move it. Water moves the most material worldwide. Wind is a very common agent of erosion, in desert regions or regions that are dry. Ice would be glacial erosion. Biological activity is our last one, and biological activity includes us moving material from place to place. So now we're going to move on to our next area of study, and our next area of study included soil. So remember, now weathering and erosion is how we form soil, so those two things are definitely connected. With environment especially, if you think about the way soils form, they're forming from those weathering agents. And things like physical weathering is going to occur more often in a cool, dry environment, whereas chemical weathering tends to happen where it's warm and wet because it helps with the actual reaction. So now, Soil, when you want to focus in on soil, you have texture. You are going to be expected to use the soil triangle, where you input your percent of clay, your percent of silt, and your percent of sand, and then you find out where all three intersect, and then that tells you what your soil texture is. So keep that in mind when you're studying. You definitely want to look over the examples we did in class. Now, soil horizons, those are your layers. You have A, which is topsoil, and that includes humus, which is in your O horizon. That's all kind of part of the A. That's your organic layer. Subsoil is your B horizon, and that includes clay. C horizon includes broken up boulders from your bedrock, which is down below. And underneath the bedrock, it's just more bedrock as you keep going deeper. Now, there's types of soil. You have residual soil, which hasn't been moved. It's located directly above the parent material that formed the actual soil. And then transported soil would be your more traditional. It's been eroded and moved from place to place and then deposited somewhere where it formed. So transported soil has been moved. Residual soil has not. And that's pretty much the major soil components. You also want to remember color. The darker the color of the soil, the more organic material. But those are your highlights for soil. So let's go ahead and move over to our next unit. And our next unit was mass movement. Now, with mass movement, there were types of mass movement. So that's the first part here. So let me scoot it over so it's nice and front and center here. So mass movement types, you have avalanche. An avalanche would be snow tumbling with debris. Slides are when it moves as a block of material, and that could be a rock slide or a landslide as long as it's moving together. Then you have slump, which is moving on a curved surface. It usually has to do with water saturating it. The water gets in, it fills the pore space, and there's no more friction, so it slides on down. Creep would be very, very slow. And evidence of creep is generally things like tilted fences or tilted buildings. It could be cracks in the road. It could break your pipes underneath your house if your house was part of the creeping situation. But it's definitely going to be movement of materials. Flow would be anything with water. Like a mud flow means you're mixing a lot of water with sediment, and it flows like a liquid. And then your last one, rockfall, that's usually caused by frost wedging. It's when it falls directly from a cliff and it falls directly down. And causes of all these mass movements can include things like noise, construction, earthquakes, mining, or even heavy rain, because that heavy rain, again, is going to reduce the friction on the surface, and that lubricates it so that it can slide down more easily. And all the while, gravity is causing all of those things to happen, because gravity is what's pulling everything down the slope to begin with. So that's your mass movement in a nutshell. So now let's take a little bit of a look at wind. Wind would be things like abrasions. Let me slide up a little bit more. So wind includes abrasion, which is the rubbing of sediment, wind-blown sediment on a rock and changing of its shape. So the wind is blowing or water is moving sediment, it rubs on it and it changes what it looks like. Saltation is for bigger sediments that can't be carried by the wind. They bounce off each other and bounce around. Loess would be a silt-blown sediment. It's a very, very small sediment, and it can be very fertile in some regions. Deflation is the removal of the top layers. We talked about removing the A and B horizons, and all that's left behind then would be the C horizon, and it makes something called desert pavement, which is, it looks like something you would do for a patio in your backyard with rocks. And that's deflation, removes it and leaves behind desert pavement. A ventifact would be a rock that was shaped by that abrasion we talked about up here. So those wind-blown sediments shape the rock, and that makes a ventifact. And that's pretty much all you need to know about wind that we haven't already talked about. So now let's go ahead and focus in on glaciers. And now glaciers can be a little bit more information than maybe you thought you were going to be focusing on. But there's two types. You have continental glaciers and valley glaciers. Continental forms from accumulation and recrystallization of snow on a large area. So basically snow falls, it freezes, and it makes a glacier on a very large area. That's a continental glacier. Valley glaciers occur in the mountains, and they're usually a result of heavy snow accumulating at the top of a mountain, and then it slides down, and as it slides down, it's going to carve out different features. One glacier feature is an esker. An esker is a winding pile of debris that's caused when the melting of the glacier, it melts and it carries all the sediment that was in it, and it starts to deposit as it moves. A moraine would be just a ridge of till along as the glacier moves. Drumlins are a result of the glacier actually moving over top of the moraine, and it makes what's called an elongated feature. It looks sort of like a teardrop. Outwash plain is the next one, and that's when the glacier starts to melt, and it's going to deposit everything as it flows away from the glacier. And then you have Kettle Lake, which results from a glacier melting in one spot, and it makes a depression. So then the depression, the water melts into it and fills it, and it makes a little lake called a Kettle Lake. And then the last one is a cirque, which is carved out of the side of a mountain. It makes a big depression in the side of the mountain. It looks sort of like an ice cream scoop. So those are your features that you want to remember and keep in mind for the unit test. And that is, again, Unit 3, Weathering, Erosion, and Mass Movement.